Hello, Akanksha. Hello. Hello, Akanksha. Akanksha,
Hello. Yes, sir.
am I audible?
Yes, yes, yes.
Okay. You are the only student attending today.
Yes, sir.
Hello. A06. त्याला काय रोल नंबर A06. Hello. A06. Hello, A06. Hello. Who is A06? Hello. Hello, A06. Hello. अरे कोण आहे तुला ऐकायला येतं का बोल की A06. Hello. Hello, A06. Ah, am I audible, A06? What is your name? Oh, साक्षी. अरे मग तुझं नाव लिहिलं नाहीस मी कसं ओळखणार तुला?
Yes, Ritik.
होय? ठीक आहे. Sakshi Metkar is joining the lecture first time. Welcome, Sakshi, for first lecture of WMC. Okay. We'll start with the mobile radio propagation. We have started that, and many more things we have completed. Means in case of the large scale path loss, what we have to find out? We have to find out first, that is loss in transmitted signal at the received side. How much is the loss, and what are the different things comes in picture? And as usual, we know that the Friis formula. Friis formula is the basic thing which is used for calculations, and we know that means many more different modules also they have found out, and this particular modules also we have discussed. So PR is PR at distance d from the transmitter is equal to PT GT GR lambda square divided by 4 pi square d square into L. L is the loss factor. So that particular loss factor is greater than 1, less than 1, or equal to 1. That we have to keep in mind. And these two equations are very important as far as the means this particular to your assignments, your MSc, your ESC is concerned. Okay, so you keep in mind that and do the preparation in that way only. So EIRP, effective isotropic radiated power, and that particular is the hypothetical concept, and it is related to the, we can say, the antenna, which is the isotropic antenna. But for the measurement purpose, we are going to use it. Okay. Spatial module, and this example for calculations of the what will the far field distance of the base station antenna, that is 2d square by lambda we have to calculate, and one can calculate that particular with the help of the equation, that is 2d square by lambda. Example 2 is related to the dBm calculation and dB calculations only. And the power issue, that particular part, and it is very simple part. I think equations, logarithmic scale is there, and with the help of that logarithmic scale one can calculate the power transmitted. Second thing is dB milliwatt that can be calculated by multiplying it by minus plus 3. You will get, you have to add dBm only. And equation is basically this particular PT, GT, GRD into lambda square divided by 4 pi square d square into L, where loss factor is 1. We have taken into consideration. Okay. Propagation mechanism मध्ये three things we have discussed, that is the reflection, diffraction and the scattering. Basic propagation mechanism which is impacting on the mobile radio propagation. Uh, for this means these basically we know that what is the reflection, what is the diffraction and the scattering. So these are the phenomena which we are going to transmit the signal, and when it is incident on any object, then it happens. As we know that means the metal reflection is 100%. We have discussed about it. Diffraction at the edges, the whatever the electromagnetic waves are incident, and diffraction is happening. That is the one particular, we can say, the electromagnetic wave is spread out, and energy is spread out. That particular part happens in the diffraction, and also the in case of the scattering also. रिफ्लेक्शन स्कॅटरिंग बद्दल बऱ्याच गोष्टी दिलेल्या आहेत. आता हॉरिझॉन्टल आणि व्हर्टिकल पोलरायझेशन कम्स इन पिक्चर वेन एव्हर वी नो दॅट दी means which band of frequencies are used uses the horizontal polarization, which band of frequencies uses the vertical polarization. That part, because loss is depends on the what type of the polarization, and in the vicinity what are the different things are there. Okay, and I have given the example related to it. It is regarding the in case of the ground wave propagation. We are using normally a vertical polarization. We are not using the horizontal polarization because the earth is a mixture of all the things, that is the, we can say, the semiconducting, conducting and all these things. That's why whatever the effect of that is the complex effect. Okay, and whenever the horizontal polarization is there, electric field vector is parallel to the ground, and as it is a parallel to the ground, it affects that the it absorbs more and more horizontal, means electric field, and that's why attenuation is more in horizontal polarization. Okay, so in case of spatial propagation, they are using the horizontal polarization. हे रिफ्लेक्शन आहे, डायलेक्ट्रिक कडून काय रिफ्लेक्शन किंवा पेनेट्रेशन वगैरे रिफ्रॅक्शन काय काय होते ते शो केली गोष्ट. Reflection at the Brewster's angle, that part we have discussed. आणि reflection model, two-ray model, हे model आहे ते similar to the whatever the we have uh, similar to we have learned in I think in a space wave model. Okay, so this is the similarity between these. Then हे इक्वेशन फार महत्वाचं आहे, हे डेरिवेशन फार महत्वाचं आहे. सिमिलर पार्ट आहे, देर इज नो एनी मच मोर कॉम्प्लिकेशन्स रिलेटेड टू दॅट. सो you can compare that to the space wave you have studied, and you can do it, no problem. These are the information given to the diffraction, and diffraction, for the diffraction module is there, that is the knife edge diffraction module. Okay, so knife edge diffraction module gives us the information about the whatever the diffracted waves are received at the receiver side, whatever the losses are. Okay, so for that, one of the equation we have is, it also takes the support of the first one, that is the two-ray model of the ground wave propagation, and extending that only, we are going to provide this knife edge, um, whatever the received power or the loss. So this is the one of the example related to the knife edges, and that particular example you have to go through and solve this example, because it is important as far as the exams are concerned. Fresnel zone, we are going to consider as a Fresnel zone is the secondary region where the secondary waves have a path length from the transmitter to the receiver. So which are the n lambda by 2 greater than in path length and then of the LOS. So whenever there is no path for the LOS, that is the line of sight, at that time what happens? The diffraction or the we can say the secondary waves comes in picture. Okay, so when the secondary waves comes in picture, so Fresnel zone is nothing but in which zone secondary waves are reached and the communication takes place. Okay, so that part is related to this one. This is about the large scale diffraction model. Okay, so whatever the notes I have, I am going to send you these particular notes and go through it. Also, large scale and small scale, these two are having one particular merged, we can say, the chapter, and that's why we are going to send you uh, this thing that is assignments related to the both, that is the large scale and the small scale, large scale path loss and the small scale padding in the multipath. Okay, so we'll start with the small scale padding and the multipath. I send you assignment and I have opened a space on the Moodle to submit the assignment. Okay, so write first assignment, convert into the PDF and upload. Okay, in 1 week you have to do this particular task. Okay, small scale padding and multipath. Multipath वर आपण बोललेलो आहे. Is nothing but it is the part of we can say the multipath only. So small scale multipath propagation. Uh, the important effects are there. Rapid changes in a signal strength over a small travel distance or the time interval. Okay. So first is rapid change in signal strength happens. Then that is the first part of the multipath propagation. Second is a random frequency modulation due to varying the Doppler shift on the different multipath signals. Um, time dispersion caused by the multipath propagation delays. These are the three main important effects. First effect I will tell you day-to-day life example. Okay, rapid changes in the signal strength. May it happens that the in any corner of the building, if you are there, and at that point any signal is going to reach means uh, rang the bell of the mobile. At that time you will get the means you are going to connect that mobile and at that time what happens, some of the points are there in the building where we are getting the better signal. But some of the points in the building are there. At that point, we are not getting the signal. Okay, so disconnection at this particular point. So because of the padding is nothing but that is the multipath propagation. We can say from different objects around you, the signals are reflected, refracted, diffracted, and all scattered and all are receiving at your mobile. And at that point, if there is the um, uh, um, addition of the all the phases is there, then you will get the better signal. Subtraction of the phases is there. There is a signal whatever you are getting, that particular signal is we can say that signal is uh, you will not get any signal on the mobile. Okay, so rapid changes. Why rapid changes? We are if we are moving at that time, it may happen, and that is nothing but the rapid changes. Random frequency modulation due to varying the Doppler shifts. Different multipath signals are there. In case of the frequency modulation, frequencies are changing, and every object which is in the past having the different, we can say, the properties, and that's why the different multipath signals will be there. So टाइम डिस्पर्शन कॉज्ड बाय द मल्टीपाथ प्रोपोगेशन डिलेज. आता टाइम डिस्पर्शन म्हटलं तर काय, तुमच्या मोबाईलच्या फोनला रिसिव्ह होणारा सिग्नल आहे तो हे चेंज असल्यामुळं जरा वेळानं होतो. म्हणजे एका डायरेक्ट असेल तो लगेच होईल, परत दुसरा असेल तो त्याच्यानंतर होईल, म्हणजे रिफ्लेक्टेड असेल, तिसरा असेल तो त्याच्यानंतर होईल. सो इट मे हॅपन दॅट द प्रोपोगेशन डिलेज आर देअर. सो दे थ्री थिंग्स वी हॅव टू कीप इन माइंड in case of the multipath propagation. That is the rapid change in the signal strength. फ्रिक्वेन्सी मॉड्युलेशनच्या मुळे फ्रिक्वेन्सी चेंजेस होत आहेत आणि डॉपलर शिफ्टमुळे डिफरंट मल्टीपाथ सिग्नल्स आपल्याला मिळत आहेत. तिसरा पार्ट आहे तो टाइम डिस्पर्शन, म्हणजे टाइम डिले प्रोपोगेशनचे वेगवेगळे आहेत आणि त्याने सिग्नल रिसिव्ह होते. फॅक्टर इन्फ्लुएन्सेस स्मॉल स्केल वायडिंग आर multipath propagation above whatever we have discussed, reflection objects and scatterers, speed of the mobile Doppler shifts, speed of the mobile and the speed of the mobile, that is nothing but the Doppler shifts, speed of the surrounding objects, and transmission bandwidth of the signal. Okay, so factor influencing small scale fading is the multipath propagation. That is the one thing. Second thing is the speed of the mobile, which gives, or the which is accountable for the Doppler shifts. Speed of the surrounding objects is nothing but the whatever the objects are there uh, on the highway. If you are traveling, and at that time whatever the in the vicinity vehicles are traveling, that particular part also comes in picture in this particular thing. Okay, so uh, speed of the objects and transmission bandwidth of the signal. So received signal will be distorted if the transmission bandwidth is greater than the bandwidth of the multipath signal, and coherent bandwidth, that is bandwidth of the multipath channel. So it may happen that the whatever the received signal changes the bandwidth because of the properties of the around whatever the things are there, and because of that only the changing or the influencing the small scale fading also. Now we'll see the what is Doppler shift. That is डॉपलर बद्दल तुम्ही मला वाटतं आपण बरंच डिस्कस केलेलं आहे. आणि डॉपलर शिफ्ट इज देअर, ऑर वी कॅन से इन केस ऑफ द रडार वी हॅव डिस्कस्ड अबाउट द डॉपलर. Okay, so what is the Doppler shift? It is the apparent change in frequency. Okay, if the object and observers are there, from observer, object is moving. Okay, and observer is sending the signals which are reaching at the observer, and it is reflected back. So mobile moves at a constant velocity v along the path segment having length d. Okay, between the point x and y. Path length difference, that is delta L is equal to d cos theta. Path length difference, this particular is the path length difference. That is d cos theta. Delta V t cos theta. That is V is the velocity, delta V is the time, cos theta. So phase angle delta phi is 2 pi delta L divided by lambda. हा काय आहे, पाथ डिफरन्स. आणि 2 पाय बाय लॅमडा मल्टिप्लाय केलं पाथ डिफरन्सला की काय होतं, तर फेज चेंज होतो आपल्याला. सो दिस वन इज द फेज चेंज, दॅट इज 2 पाय v delta t divided by lambda into cos theta. So Doppler shift fd is equal to 1 by 2 pi delta phi divided by delta t. Okay, so delta t delta gets cancelled, and that's why v by lambda cos theta is there. V by lambda cos theta is nothing but the Doppler shift. So depends on what? Depends on the velocity of the object. That is the one thing. Or then second thing is lambda. Lambda is the wavelength of the signal, and cos theta, whatever is the angle. So in this way the Doppler shift happens. Only thing is that here both, that is the mobile subscriber as well as the base station, going to transmit and receive the signal. Is it or not? So In case of the Doppler, we have discussed Doppler about the one-way communication. But in case of this particular mobile communication, it has the effect of two-way. Only thing is that base station is the standstill and mobile station or the subscriber is the mobile station. Okay, so mobile station also transmit the different signal frequencies. Also, it receives the different signal frequencies, and base station transmit the signal frequencies. Also, receive the signal frequencies. So it is the complex. We can say the example of the Doppler shift we can take into consideration. Okay, only thing we have to keep in mind that the ft is equal to v divided by lambda, where v is the velocity of the mobile subscriber and lambda is the wavelength of the transmitted signal. Maybe it is from mobile towards the base station or base station towards the mobile. Okay, so into cos theta is the angle to which the base station. So S is the base station, and whatever the car is shown, that particular car is moving from X to Y. Okay, so this particular module you have to keep in mind, and means if you are not getting anything, then you can revert that. Hello, Shraddha. Shraddha.
Yes, sir.
Yes. You are attending the first time lecture.
Yes, sir. Because of the internship timing, I wasn't unable to join the previous lectures. And
Oh,
some of the times I was getting some internet issue. That's why.
okay, okay, okay. Where you are doing the internship now?
In Kolhapur only, sir. I'm doing in web development.
Yeah. Okay. How many offers you have now?
DXC and another is TCS Ninja, sir.
DXC and TCS means. Okay. Have you filled the link?
Yes, sir.
Uh, Prasik Sawan has sent the link related to the uploading your photo and
Yeah,
letter
sir.
of intent or the
I have
offer
done
letter.
it yesterday only. I have completed it.
Okay, okay,
Yes, sir.
okay. Very good, very good, very good.
Thank you, sir.
Okay, okay. Nikita, Nikita is there. निकिता जॉईन झाली आणि परत गेली वाटते ती. All of you take the pen and notebook and pen. Write this problem and solve this problem. Uh, Consider a transmitter with radiated sinusoidal carrier frequency 1850 megahertz for a vehicle moving 60 mph miles per hour. mph is miles per hour. Compute the received carrier frequency if the mobile is moving A, directly towards the transmitter, directly away from the transmitter, in the direction perpendicular to the direction of arrival of the transmitted signal. So this is the example, and as we have discussed about, that is FD we have to calculate. Here we have to calculate the compute the received carrier frequency. Received carrier frequency FD is equal to V by lambda into cos theta. So that particular part we'll discuss. So carrier frequency FC is 1850 megahertz. Lambda is equal to 3 into 10 raised to 8 into 1850 into 10 raised to 6. That is 0.162 is the lambda. V is 60 mph and we have to convert into the meter per second. How one can convert the meter per second? This 60 mph. Can you tell me? Yes. So 60 mph is converted into the kilometer first, kilometer per hour. After that, convert into the kilometer per second and convert into the meter per second. So this is the procedure. Okay. Conversion factor for the miles into kilometer is 1.6. 60 into 1.6 is the kilometer per hour. Then hour, that is divided by 60 into 60. Then seconds, and it is can be calculated, that is 26.82 meter per second. Vehicle is moving directly towards the transmitter. Doppler shift in this case is positive and received frequency is given by the equation. म्हणजे काय? तर vehicle directly towards, म्हणजे ज्यावेळी vehicle towards the destination कडे जाते त्यावेळी पॉझिटिव्ह असतो तो. That's why F is equal to FC plus FD. FC plus FD. So 1850 into 10 raised to 6 plus 2682 divided by 0.162. Okay. So cos theta is taken as the cos 0, that is 1, and they have calculated this one. So FC plus or minus FD. That particular part we have to keep in mind, and we can solve examples. Okay, so vehicle moving directly away from the transmitter, Doppler shift in the case is the negative, and hence the received frequency is given by F is equal to FC minus FD. Okay, so FT minus FD, it is 1850 1849 99984. Okay, so this particular is the frequency in megahertz. We can write also that 1849999834. That is the value of this particular. So third part is moving. The vehicle is moving perpendicular to the angle. Then it's 0. Cos 90 is 0, and the received signal frequency, the same transmitter, is 1850. That we have to keep in. With cos theta is equal to 0, we have calculated for when the vehicle is coming towards the base station, vehicle is going away from the base station. That if it is coming towards, it is positive FC plus FD. If it is going away, then FC minus FD. And it is perpendicular, means cos theta is 90 and theta is 90 and cos theta is 0, and that's why there is no change in the frequency. So this is the example. These examples are very important examples as far as your exams are concerned, and that's why it is important to note these particular things and do it. Impulse response model of a multipath channel. Hello, Prachi. Prachi is there. Hello, Prachi. Prachi Karande. Am I audible? Hello, Prachi.
Yes, sir.
You are attending the lecture first time?
No, sir. No, sir.
How many lectures you have attended?
Last 2 lectures, sir.
Okay. What about the internship? Hello, Prachi. Are
Yes,
you
sir.
doing the internship? Where are you doing the internship?
Pune, sir.
In Pune. Okay.
Yes.
Now it's on, or you are there in Pune?
I'm there in Pune, sir.
Okay. In which company?
Sidmac, sir. Sidmac Mechatronics.
Okay. What they are going to do?
Making PCB and model of engine.
Very good. Very good. Very good.
Yes, sir.
Okay. Okay. How is the experience?
It was great, sir.
Okay. Okay. What about your placement?
Not at all, sir.
Why it is so? What are the lacunas? Hello.
Hello?
Sachin?
Yes, sir.
Ah,
सर आता
uh,
चालू आहे म्हणजे फॉर्म वगैरे फिलअप केलाय.
फॉर्म फिलअप केला बर. ब्रोसेला का नाही आलीस तू पण?
सर मला ते इंटर्नशिप मध्ये चालू होती आणि मी लेट फॉर्म भरायचं पण माझं हे नव्हतं म्हणजे लॅपटॉप अवेलेबल नाहीये ना इथे
बर बर बर.
त्यामुळे आणि मी नेट कॅफे पण बंद होतं ना त्यामुळे मग नाही फिलअप केला फॉर्म तो. मग त्या बायजूसचा फिल करणार आहे.
अरे बायजूचा तर मी लॉक करून टाकला. हा?
ओके सर.
मी 4
ओके
दिवस
ओके
ठेवला लॉक केला.
सर ते
तू
इंटर्नशिप मी मेल बघितला होता पण ते सीन करून पुन्हा मला लक्षातच राहिलं नाही. ते इंटर्नशिप मध्ये सकाळी जाते ना मी त्यामुळे यायला पण लेट होतो त्यामुळे राहिलं सर. ते लॉक केलंय का तुम्ही?
हो हो आता बंद करून टाकलं. तू काय कर, नाव टाक आणि पाठवून दे मला व्हॉट्सअप वरती. मी ऍड करतो नाव
ओके
तिकडे.
सर. ओके चालेल चालेल चालेल.
दुसरं ते तुमचं तुमची कंपनी तुम्हाला हायर करणार आहे का?
अजून तरी त्यांनी काही सांगितलं नाहीये पण सध्या
हा,
ते इंटर्नशिप प्रोव्हाइड करतायत. ते परफॉर्मन्स वरती सर डिपेंड आहे.
ठीक आहे. ठीक आहे. चालेल.
हा
ठीक
हा. थँक्यू.
ओके ओके. No problem at all. Impulse response model of a multipath channel. We'll discuss. आत्ताच आपण डॉपलरशिप बद्दल बघितलं, डॉपलरशिपची इक्वेशन्स बघितली, त्याचं एक एक्झाम्पल बघितलं. तर व्हेरी सिम्पल एक्झाम्पल इज देअर अँड व्हेरी सिम्पल फॉर्म्युला इज देअर. FD is equal to V divided by lambda into cos theta. That is the formula, and with the help of that formula, we have to calculate the Doppler frequency, change in the frequency. If any object is moving towards the observer, positive will be the frequency. Any object moving away from the observer, negative will be the frequency. Only thing this you have to keep in mind. The wireless channel characteristics can be expressed by impulse response function. The channel is time varying channel when the receiver is moving. Channel is time varying and the receiver is moving. Let us assume the first that time variation due time variation due strictly to the receiver motion t is equal to d by v. Since any distance d is equal to v into t, time and velocity. Received power will be combination of the different incoming signals. The channel characteristics or the impulse response function depends on impulse response function depends on the distance d between the transmitter and the receiver. Okay. They have shown here the diagram or the figure of the impulse response model of a multipath channel. Receiver is V along the ground at some constant velocity V. The multipath components that are received at a receiver will have different propagation delays depending on V. Distance between transmitter and receiver. Hence, the channel impulse response depends on the V. इम्पल्स रिस्पॉन्स कशावर अवलंबून आहे तर तो डिस्टन्स वरती अवलंबून आहे आणि ते डिस्टन्स किती आहे त्याच्यावरती. सो रिप्रेझेंट्स एक्स ऑफ टी रिप्रेझेंट्स द ट्रान्समिटेड सिग्नल, वाय ऑफ डी ऑफ टी रिप्रेझेंट्स द रिसीव्ड सिग्नल at position T, and h of T represents the channel impulse response, which is depending on the T. Hence, time varying T is equal to Vt. मी बऱ्याच वेळा ही सगळी इक्वेशन्स आहेत ती SS मध्ये बघितली असाल, DSP मध्ये बघितली असाल, तर ते आपल्याला अप्लाय करायचं आहे याच्या वेळी. मल्टीपाथ चॅनल मॉड्यूल कसं असतं बघा, बेस स्टेशन इथं आहे, इथं बिल्डिंग आहे, त्याच्यावरून रिसिव्हर मिळालेला आहे, इथं दुसरी बिल्डिंग आहे, त्याच्यावरून मिळालं, इकडे दुसरी बिल्डिंग आहे आणि डायरेक्ट आहे. सेकंड, सो फर्स्ट इज द डायरेक्ट पाथ, सेकंड इज द फ्रॉम येलो बिल्डिंग, third is from the green building, and fourth is from the violet building. All these are the channel multipaths, and a receive channel is there, receive signal is there at the receiver on the mobile one. Okay, so this part, below part, I am going to show you. Second thing is in the base station to the this one means two multipath or two path are shown here in the mobile too. Okay, so these are the things happening at the mobile communication. So impulse response module of a multipath channel has X of T is the transmitted signal. Wireless multipath channel has the whatever the response is there, H D comma T, and Y of T is the received signal, we can say. So the channel is a linear time varying channel where the channel characteristic changes with the distance, and hence T is equal to D by V. T is, that is the time, is equal to distance divided by the velocity. तो किती टाइम रिसीव्ह व्हायला लागणार आहे ते टी वर डिपेंड आहे, आणि टी डिपेंड आहे डी आणि व्ही वरती. डी इज द डिस्टन्स and v is the velocity. Y of d comma t is the received signal is equal to x of t is the transmitted signal convolved with the h of d comma t. So this can be written as integration from minus infinity to plus infinity x of 2 into h of d comma t minus 2 into d. For the causal system, h d comma t is equal to 0 for t is less than 0, and hence y of t comma t is equal to minus infinity to t. Minus infinity to t, x of 2, h convolved with, that is multiplied with, in this case, d comma t minus 2 d2. Okay, so very simple representation of the impulse module they have shown here, where the response of the wireless multipath is, or the characteristic of wireless multipath is there with the h d comma t. Output is, that is the received signal y of t, and the whatever the transmitted signal is x of t. Impulse response module, D is equal to V of t, V into t. Assume V is constant over time. Assume V is constant over time. Y of V into t comma t is equal to minus infinity to t x to h dt t minus 2 into d2. तर त्यांनी काय केलं, d ऐवजी vt टाकलं इकडे. आणखीन हे एक्झाम्पल सॉल्व्ह केलेलं आहे. y of t इक्वल टू मायनस इन्फिनिटी टी x of 2 h into v of t t minus 2 d2. x of t convolved with h of h into v of t dt is equal to x of t convolved with h t comma t. We assume v is constant over short time. Okay, x of t transmitted waveform, y of t received waveform, h of t impulse response of channel depends on t. Okay, and therefore t is equal to d by 3. Also, to the multiple delay for the channel for the fixed value of t, tau is the multipath delay, and a channel for the fixed value of t, then one can write it as y of t is equal to minus infinity to plus infinity x of tau h of t minus 2 into d2 is equal to x of t convolved with h of t comma tau. So impulse response module, bandpass channel, bandpass channel impulse response module, bandpass channel impulse response module is shown here. and baseband equivalent channel impulse response mode. Okay, so only real part we are going to take into consideration of that, and then we'll get output, that is y of t is equal to x of t convolved with h of t comma 2. Upper one is the band pass channel impulse response, and baseband channel is nothing but whatever the information signal channel response is there, that is c of t is equal to 1 by 2 hv t comma 2 into r of. So it is c of t convolved with 1 by 2 hv t comma 2. So it is a process of the convolution where we are going to consider the impulse response of the medium. That is the one thing we have to keep in mind, that, and convolve with the transmitted signal, and that is the received signal at the receiver side. Some measurements are there related to the small scale, and how one can do these particular measurements. That part is also included. That is, several methods are there. Direct RF pulse is there. Spread spectrum sliding correlator channels sounding is there, and frequency domain channel sounding is there. These are the several methods of the multipath measurements. These techniques are also called as the channel sounding techniques. Channel sounding techniques, channel conversion techniques, or channel, we can say, upgradation techniques also. So direct RF pulse system is the one of the things. Spread spectrum sliding correlated channel sounding, and frequency domain channel sounding. Small scale multipath measurements, in which the multipath structure is very important for the small scale padding. मल्टीपाथ स्ट्रक्चर आता प्रत्येक केसमध्ये आपल्याला काय माहित नसणार आहे मल्टीपाथ स्ट्रक्चर कसं असेल, पण वन कॅन take cognizance, or we can say the take survey, and from that particular survey, normally what type of structure is there, that can be represented in case of the multipath structures. So several methods are there. Direct RF pulse system is the one thing. Second thing is the spread spectrum sliding correlated sounding channel are there, and the frequency domain. These techniques are also called this thing. So direct pulse system, which gives this particular diagram, that is the pulse generator. Fc is equal to pulse generator is given, and that is nothing but the impulse response of that, and add the outputs of transmitter is there. Pulses they are going to receiver side. PBF, that is the band pass filter is there, and bandwidth is 1 by 2 by 2 TBV. Resolution is equal to pulse width detector and the digital oscilloscope, where we are going to measure this particular pulse. So direct RF pulse system for what? Small scale multipath measurements. Direct pulse system has problem like subject to interference, subject to noise due to the wide pass band filter required for the multipath resolution. The phases of the individual multipath components are not received due to the use of the envelope detector. So many more direct pulse system has the many more problems or limitations are there, like the subject interference, subject noise due to the wide pass band filter required, and the phases of the individual multipath components are not received due to the use of the envelope detector. And these are the limitations of the direct pulse. Spread spectrum मध्ये काय आहे? Spread spectrum sliding correlated channel sounding. This is the probing signal is wide band, but the receiver is a narrow band. Carrier signal is spread over a large bandwidth by mixing it with the pseudo noise. That is means basically spectrum is nothing but adding. They are going to add the pseudo noise, and that's why they are going to improve on the bandwidth. Means they are going to increase the bandwidth, and as they are going to increase the bandwidth, sequence having the chip rate of PC at the receiver signal is desperate using the same PN, that is the pseudo random noise. The transmitter chip clock rate is a little faster than the receiver chip clock rate, and as a result, the sliding correlator is there. If the sequence are not maximally correlated, then the mixer will further de-spread the signal. So spread spectrum sliding correlated channel sounding, that is nothing but they are going to add the pseudo noise in the FC signal. They are going to transmit it, and the receiver side band pass filter. Here they are going to, that is the PN signal or the pseudo noise. They are going to add in this particular part and then band pass filter, and then they are going to find out it in the digital oscilloscope or the digital CRO. CRO. Spread spectrum sliding correlator channel sounding has C rate of RC is equal to 1 by TC. Bandwidth is 2 RC because they are going to improve the bandwidth because they are going to add the pseudo noise, and as whatever the bandwidth is there, it's a doubles. Processing gain PG is equal to RC divided by RBB. That is nothing but 2 tau BB divided by TC. Signal to noise ratio at the output divided by signal to noise ratio at the input. It is nothing but the processing gain. This particular is the processing gain. Time resolution is delta T to TC is equal to T2 divided by RC. Okay. Sliding factor is the gamma, and it is equal to alpha divided by alpha minus beta. Alpha is the transmitter chip rate. Transmitter chip rate is the alpha, and the beta is the receiver chip rate. So this is about the sliding channel. स्प्रेड स्पेक्ट्रम मध्ये अगोदरच नॉइज त्यांनी तयार करून घातलेला असतो, आणि त्यामुळे ऍडव्हान्टेजेस काय, इम्प्रूव्ह द कव्हरेज रेंज युजिंग द सेम ट्रान्समीटर पॉवर. ट्रान्समीटर रिसीवर synchronization is eliminated in sliding of the correlator. Real time we cannot do it. Associated with the time required is more, and the phase information is lost. Here also the phase information doesn't get anything. So we have discussed today this particular part, that is the small scale fading, in which first part we have discussed about the uh, small scale multipath propagation, on which factor it depends, factors influences for small scale fading, what are these particular, and Doppler shift we have discussed completely. One example we have seen, an impulse response of the model for the multipath channel, that particular part, and multipath channel, how it affects, and all these things we have discussed. After that, the small scale multipath measurements, and 3 different types are there of the direct pulse system and the spread spectrum system channel. And third one we have not yet um, um, discussed. Okay, so these are the things we have discussed. I am going to send this PPT on your this thing WhatsApp group, and you go through it. Whatever we have taken, it is the important, and we will stop here for good. Okay.